Within the vastness of the universe, humanity is not that big of a deal. We're not here because we're meant to be, we're just here. If mathematical predictions are correct, we might only have 760 years left. What would be the cause of our extinction? What would we do if we knew exactly when our existence would come to an end? And could we delay the inevitable? This is what if, and here's what would happen if we knew the exact time when humanity goes extinct. In 1993, astrophysicist J. Richard Gott made a daring prediction using statistics. He calculated that there's a 50% chance that human life will end before the year 2779. That gives us 760 years to make our final arrangements, possibly pass the Earth to a new life form, or even leave the planet altogether. Fast forward to the future. On April 13, 2029, the near-Earth asteroid named Apophis will pass within 31,000 kilometers of our planet. It will be 10 times closer to Earth than the Moon. However, it won't impact Earth. Instead, it will safely continue its path around the Sun. Reproductive technology would advance, allowing parents to select genetic traits for their future babies. The global population would reach around 8.5 billion and face a crisis. Ecosystems would radically change due to increased CO2 levels, and space junk would pose challenges for space travel. Assuming we solve the space junk problem, we'd establish lunar bases and expand our presence beyond Earth. Unfortunately, on Earth, global warming would escalate, surpassing safe limits. The Great Barrier Reef and the Amazon rainforest would suffer severe damage, and numerous species would go extinct. This scenario would initiate the next mass extinction event caused by humans. The Earth's population would reach 10 billion, and extreme weather events would ravage the planet. Parts of the world would become uninhabitable, leading millions of people to seek refuge elsewhere. Advancements in biotechnology would allow humans to merge with technology on a biological level, with artificial organs, synthetic blood, and nanoscale brain interfaces becoming a reality. Sea levels would rise drastically, forcing significant changes worldwide. Hundreds of millions of people would need to leave their homes, and large-scale evacuations and resettlement programs would be necessary along coastal areas, costing humanity trillions of dollars. The declining fertility rate and significant casualties from environmental conditions would stabilize Earth's population at 11 billion by the 2180s. Humanity would begin expanding into the solar system, with asteroid mining and the terraforming of Mars underway. Access to space technology would increase, but a new form of terrorism would emerge, potentially hijacking spacecraft to redirect asteroids towards the Moon, Mars, or Earth. Space colonies would be particularly vulnerable due to the lack of infrastructure. Spaceships powered by antimatter propulsion would enable travel beyond the solar system, while unmanned probes would explore distant galaxies. By the end of the 23rd century, confirmation of microbial alien life on a nearby exoplanet would be obtained. Advancements in nanotechnology would lead to the transformation of the general public into transhumans or cyborgs with enhanced abilities. Humanity would progress to a Type 1 civilization on the Kardashev scale, harnessing all of Earth's energy and controlling the weather, climate, earthquakes, and even building cities at the bottom of the ocean. Manipulating the sun's energy and constructing megastructures like Dyson spheres or feeding the sun's mass into a black hole would be considered. These events could ultimately lead to humanity's disappearance from Earth, potentially moving to previously established space colonies or being succeeded by a biotechnologically engineered species. However, this timeline is a rough estimation based on statistical models and expert predictions. Knowing the date of extinction could have various effects on our lives. It might lead to neglecting the environment and indulging in short-term happiness. Society could become more violent, self-destructive, and prone to conflict. Alternatively, humanity could unite and search for new habitable places beyond our solar system, establishing stable colonies to ensure the survival of our species. This is a planetary emergency, but it's essential to remember that the calculations predicting our extinction are probabilistic, not certain. Other predictions suggest that our extinction may occur 10,000 years from now, allowing us to witness phenomena such as polar reversals and computer advancements. The way we live our lives would be influenced by the knowledge of our fate.
Evacuation,
But
please remain calm and
board your space shuttles. You know, each EO, humanity might not have to leave the Earth in your lifetime. We should start preparing early on. Not only could it take centuries to set up the relocation program, but it would also take generations to move to a potential new home. That right there is Proxima Centauri b, or just Proxima b. It's the closest potentially habitable planet out there. Its temperatures are in the bearable range, and it could have just the right breathable atmosphere. Only have to get there. How long would our journey last? How many people would we send to populate the new world successfully? And what if it turned out that Proxima b wasn't as habitable as we thought? This is what if, and here's what would happen if we relocated humanity to Proxima b. When astronomers started finding planets outside our solar system or exoplanets, we realized that there are many worlds out there. That meant that Earth doesn't have to be our home forever, and that we don't have to die with our planet when the sun engulfs it in some 5 billion years from now. That we found over 4,100 exoplanets, we've learned something rather disappointing. Not all exoplanets are suitable for humans to live on. Most of the worlds we've encountered are either ice giants like Neptune or gas giants like Jupiter and Saturn. Only 161 of those planets are terrestrial, like Earth. And when it comes to sustaining human life, being terrestrial isn't quite enough. Proxima b is very promising. It orbits a red dwarf star called Proxima Centauri in a system with 3 stars. Proxima Centauri is small, with only between 7.5% and 50% of our sun's mass. That's a good thing because the red dwarf Proxima Centauri burns at a lower temperature due to its smaller size. It takes stars like Proxima Centauri much longer to burn through all of their hydrogen supply. Because of that, Proxima Centauri has a lifetime of trillions of years, while our sun has an expiration term of 10 billion years. That alone makes Proxima b a good candidate for relocation, along with its orbit lying in Proxima Centauri's habitable zone. That means there's the potential for liquid water and comfortable surface temperatures. If we're lucky, Proxima b would have an atmosphere that we could breathe, and if it does, the surface temperatures would be in the range of 30 degrees Celsius. I don't know about you, but I'd move there right now. I just need to warn you that there are a few problems. A trip to Proxima b would be long and very dangerous. Proxima b might be the closest habitable exoplanet we've got, but that doesn't mean it's close. The red dwarf star Proxima Centauri is about 4.3 light years away. That means that if you could travel at the speed of light, it would take you 4.3 years to get there. Unfortunately, nothing we've built so far can reach that kind of speed realistically. A trip to Proxima Centauri in a space shuttle would take approximately 165,000 years, give or take. That's right. Some of the colonists would be born in transit, some of them would never see the Earth, and some of them would never see Proxima b. They just live their lives aboard the spaceship and die in space. So, how many humans would we need to send on a mission exactly? Well, according to some calculations, 98 people would be just enough. Their descendants would arrive at Proxima b with enough genetic diversity to populate the entire planet. And that's accounting for possible cases of infertility, inbreeding, and sudden deaths. In those calculations, the crew would be traveling on something faster than a space shuttle, and their mission to Proxima b would only take approximately 6,300 years. But don't be fooled, this is all theoretical and speculative at the moment. Surprised? Technology is constantly improving. Right now, a scientific and technological program called Breakthrough Initiatives is looking at how we can reach the neighborhood of Proxima Centauri within 1 generation. Their project, Starshot, is working on an ultralight unmanned probe that would reach the star system in just 20 years. Signing up for such a mission may seem appealing, but there are several challenges to consider. Firstly, Proxima b, the potentially habitable planet in the Proxima Centauri system, is extremely far away. We cannot even determine if it has an atmosphere, and if it does, it may not be conducive to human survival. Surface temperatures on Proxima b could be as low as minus 40 degrees, requiring spacesuits and oxygen tanks for exploration. Additionally, Proxima b could be tidally locked, meaning one side is always facing the star, while the other side remains in darkness. Furthermore, extended spaceflight can have detrimental gravity environment would lead to loss of muscle and bone density, increased exposure to space radiation, and changes in microbiomes, immune systems, and physiology. The crew members would not be the same type of humans as we are due to these changes and the challenges of long-term space travel. Another concern is the possibility of mission abandonment or altered objectives by the crew. They could forget farming techniques taught to them and change their values and culture over time. There is even a possibility that they might return to Earth and seek revenge for the years spent in space. Undertaking such a mission involves significant risks and challenges. It would require designing and building a vehicle, carefully selecting and supplying the space travelers, and creating self-sustaining systems for food, water, propulsion, navigation, hibernation, and life support. Additionally, we lack concrete knowledge about the habitability of Proxima b. Given these considerations, it may not be wise to pursue a mission to Proxima Centauri. Perhaps a better idea would be to focus on building a megastructure closer to our solar system, but that is a story for another what-if scenario. As for meeting a time traveler, despite the concept's intrigue, we have yet to encounter any definitive evidence of such individuals. If we were to prove someone's time travel, it would revolutionize science and potentially challenge Einstein's theory of relativity. Einstein's theory posits that space and time are intertwined, forming a space-time continuum. Gravity can influence space and time, and thus theoretically, extremely massive objects like black holes can bend time. Being close to a black hole, such as Sagittarius A, would cause time to pass slower compared to Earth. Alternatively, traveling at speeds approaching the speed of light would result in time dilation, where time passes slower for the traveler relative to those on Earth. While these concepts suggest the possibility of time travel, no concrete evidence has been found, and the nature of time travel remains uncertain. If we were to encounter a time traveler, determining their authenticity would be challenging. Their time machine, if it exists, would depend on the theoretical principles of time travel, which are currently unknown. In such a scenario, establishing a set of rules for time travelers to follow would be crucial. However, without any confirmed time travelers, we cannot outline such rules or anticipate the consequences of breaking them. The topic of time travel remains a fascinating subject for scientific exploration and speculation. 223 years would have passed back at the station, making you a time traveler into the future. But what about traveling back in time, like John Titor claimed to have done? According to Titor, his time travel was made possible by a machine called the 204. This device manipulated gravity using 2 microsingularities packed inside, and it also had gravity sensors to fix the machine and time traveler in place. Similar to the iconic time-traveling DeLorean, Titor installed this machine in a car, which could take him as far as 60 years from his own time. However, determining whether Titor truly traveled in time or fabricated his story remains challenging. Proving the authenticity of a time traveler might be even more difficult than time travel itself. Time travelers could potentially make accurate predictions about the future, demonstrate futuristic technologies, or even undergo genetic testing to support their claims. One possible way to prove time travel is real would be for a time traveler to take someone with them on their next adventure. In 2009, physicist Stephen Hawking held a party exclusively for future time travelers. He intentionally delayed sending out the invitations until after the party, believing that if time travelers existed, they would have arrived before the invitations were sent. However, no one showed up. This doesn't necessarily mean time travel is impossible. There is a chance that future time travelers might utilize wormholes or space-time bridges, as predicted by the theory of general relativity. One major issue with wormholes is that they tend to be microscopic and collapse rapidly, making them unsuitable for human travel. It's possible that no one attended Hawking's party because time travel is imprecise, and the guests from the future may have arrived too late. Alternatively, it's conceivable that time travel to the past is strictly prohibited among time travelers to prevent potential disruptions to their own timelines. It could also be that time travelers are cautious about transmitting diseases that information or technology related to time travel is highly classified, known only to a select few individuals. Moreover, it is plausible that traveling backward in time is fundamentally impossible, and time can only move forward, not backward. The case of John Titor may ultimately be revealed as a fabrication, but we have a few more years until 2034 to know for certain. In a sense, we already have time travelers in our lifetime. Astronauts aboard the International Space Station age slower due to their velocity of 8 kilometers per second. However, this difference is only measured in hundredths of a second. Please note that the concept of time travel is still largely speculative, and there is currently no concrete evidence to support its existence. Invited to a reception for time travelers hosted by Stephen Hawking, the party will take place at the University of Cambridge, United Kingdom, on June 28, 2009. No RSVP required. And hey, if you have a chance to jump in a spaceship and enjoy the time-traveling effects of a black hole, do it. Just make sure not to fall into that gravitational monster. But that's a story for another what-if scenario. Foreign. If you could take in all of human history in the blink of an eye, well, from the first steps out of the slime to the first steps on the moon, that's exactly where we are in cosmic terms. But in that short amount of time, we've done quite a bit. What would you see if you traveled 1 billion years into the past? Did Earth ever look like a giant slush ball? How far back would you have to go to see the first humans? And are we already going extinct? This is What If, and here's what would happen if you went 1 billion years into the past. In a sense, we're all time travelers. We travel into the future at the rate of 1 second per second. But if you want to go backward in time, you'll need to go faster than the speed of light, according to Einstein. Or maybe your time machine would jump through wormholes, hypothetical tunnels that connect 2 different points in space-time. However you decide to travel through the jumbled mess of time, you'll see the effects and then the causes of the most powerful forces that shaped our world. You might leave wondering how many times did the Earth freeze as you watch history unfold or refold or whatever. You might be surprised at the toll humanity has taken on this planet in such a short amount of time. If you start in 2021 and move backward, you would watch the 6th mass extinction event happening right now, known as the Holocene extinction. We are currently living through one of the most destructive periods of our time, caused by human activity. As humans destroy coral reefs and rainforests, the numerous wildlife and plants that depend on these ecosystems die with them. According to the International Union for the Conservation of Nature, 67% of endangered species could be extinct in 100 years. And since most of these extinctions are undocumented, we won't even know about what we've lost until it's gone, maybe not even then. Visit the 18th and 19th centuries, and you could watch the pollution created by the Industrial Revolution reverse back into the smokestacks. Cities would shrink down and return to their roots as rural farmlands. While this would let you see the explosion of the human race in terms of population and pollution, if you want to retrace our first steps, you'll need to go back even farther. Tour the planet 200,000 years ago, and you would witness the arrival of our species, Homo sapiens. Jump back 7 million years to northern Chad, and the oldest known species of humans, Sahelanthropus chadensis, could stroll right by you. Known as the mysterious link in our chain, he looked ape-like, but was the first to walk upright. He seems friendly enough. But travel back to 60 million years ago, and you'll see the first primates emerge from the humid rainforests of Asia. Okay, step back to 65 million years ago, and you find yourself under the giant asteroid that created a global extinction event. The impact caused a tsunami and filled the air with dust and debris. The crash also set off massive volcanic eruptions across the world. With the sun blacked out and the land flooding, this event, mammals like us may never have taken over the planet. Go back 130 million years and you'll see the first flowers bloom. As you travel 200 million years back in time, you'll witness the breakup of Pangaea, the mass of land that will become the continents. As the land breaks apart, the lava eruptions will be so massive that they kill almost 80% of the species on Earth. Okay, keep going back another 20 million years and watch the first early mammals, small and nocturnal, crawl around in the dark. And if you go back to 230 million years ago, You could watch the early dinosaurs walk for the first time on two legs. But before that can happen, the Earth has to go through what would be known as the Great Dying, also called the Permian extinction. 95% of all species on Earth died, but you could also watch the Earth's land masses come together to form Pangea. Now, you could take a walk from Argentina to China. But things get interesting around 375 million years ago. You would watch marine animals walk onto land for the first time. Maybe you would see a tiktaalik, which looks like a salamander mixed with a fish. This strange creature would later evolve into mammals and amphibians. But just like every species you saw before, this growth doesn't happen without a cost. And now we're at the first extinction event, the Ordovician extinction. It occurs when ice sheets spread from the polar caps into the oceans. Almost 70% of all sea life died off during this planet-wide freeze over 460 million years ago. Okay, keep going back and you could see how life started underwater, called the Cambrian explosion. The lineage of most of the species on our planet today can be traced back to this milestone. But scientists are still unsure how this unique event happened. Between 635 and 850 million years ago, the Earth froze over twice. Once for almost 60 million years and the next time for 15 million years. One theory suggests that the Earth was only covered in a thin film of ice, allowing the sun's rays to seep through and plant the seeds of life below. But go back 1 billion years in history, and you'll be surprised to find, well, not a lot. During this time, red algae are forming spores to reproduce. Cells are coming together to form larger organisms. Life on Earth is microscopic and not very threatening. But nothing has been more vicious to our planet in such a short amount of time as humans. But maybe humans will set things right eventually. There could be a change in our planet or our hearts that might set our future on a different path. Or maybe, like the dinosaurs and Neanderthals, we would just be replaced by something else. So let's take our time machine and find out. What if you traveled 1 billion years into the future? Well, that's a story for another what if. If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes, or would it be frozen in ice? What if you traveled even further to 1 million years in the future? Would all of the oceans have evaporated, or would it have become one giant water world? Okay, now what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? This is What If, and here's what would happen if you traveled 1 billion years into the future. Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic, so how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? Well, let's take a look into the future and find out. Just under 10,000 years from now, we're going to run into a big problem called the DCA Millennium Bug. In the year 10,000 AD, software issues will arise because many computer systems were not programmed to accommodate dates beyond this time frame. This could lead to significant disruptions and challenges in various aspects of society that rely heavily on technology. It's important for us to address these concerns and plan for the long-term survival of our species if we want to have any chance of thriving. Calendar year won't encode dates with more than 4 decimals. This means that when encoding a calendar year, only up to 4 decimal places can be used. For example, the year 2022 would be encoded as 2020-2.0. Regarding future events, it's important to note that predicting events millions or billions of years into the future is highly speculative and uncertain, as many factors can influence the course of events over such long periods of time. However, based on current understanding, in around 10,000 years, genetic differences and traits between humans might become more evenly distributed around the world, potentially contributing to a more harmonious coexistence. In 20,000 years, It is speculated that future languages will have evolved to the extent that they will only contain about 1% of the core vocabulary words of their present-day counterparts. Around 50,000 years from now, the Earth may enter a new glacial period, initiating a new ice age. Additionally, Niagara Falls is projected to have eroded into Lake Erie completely. In approximately 250,000 years, the Loihi volcano in Hawaii is expected to rise above the water and form a new island. In 500,000 years, there is a possibility of an asteroid with a diameter greater than 1 kilometer hitting Earth, potentially resulting in a large crater and significant global consequences. In 1 million years, there might be another supervolcano eruption, potentially releasing a massive amount of ash and lava. The nearby star Betelgeuse may also have exploded into a supernova, becoming visible from Earth even during the daytime. In 2 million AD, human settlements throughout the solar system are envisioned, which could lead to the potential evolution of humans into other species adapted to their specific environments. In 10 million years, a substantial part of eastern Africa might break off, forming a new ocean basin. In 50 million years, Africa is projected to collide with Eurasia, closing off the Mediterranean Sea and giving rise to a new mountain range. In 60 million years, the Canadian and American Rockies are expected to erode entirely. In 80 million years, all Hawaiian islands are anticipated to be below the water. In 100 million years, there is a possibility of another asteroid impact similar to the one that caused the extinction of the dinosaurs. In 250 million years, all of Earth's continents might have fused together, similar to the ancient supercontinent Pangaea, forming a new supercontinent called Pangaea Ultima. In 400 to 500 million years, Pangaea Ultima is predicted to separate once again. In 500 to 600 million years, there is a possibility of a gamma-ray burst occurring within 6,500 light-years from Earth, which could have severe consequences for life on Earth. In 600 million years, the Moon is estimated to be so far from Earth that total solar eclipses will no longer be possible. Additionally, the increasing luminosity of the Sun might halt plate tectonic movement on Earth. In 800 million years, carbon dioxide levels are projected to drop significantly, leading to the disappearance of free oxygen and ozone from the atmosphere, potentially affecting complex life on Earth. Finally, in 1 billion years, the increased luminosity of the Sun is expected to raise temperatures on Earth to an average of 47 degrees Celsius, causing the oceans to evaporate and making the planet uninhabitable for complex life as we know it. Please note that these are speculative future scenarios based on current scientific understanding, and they should be treated as such. Contact with the aliens. Communication would be a significant challenge since we would have no previous knowledge of their language or means of communication. Linguistics experts would work tirelessly to decipher any possible message or determine a common ground for communication. Meanwhile, psychologists would study the aliens' behavior and intent to understand their motives and assess their level of friendliness or hostility. Combat specialists would develop contingency plans to ensure the safety and security of humanity in case the aliens posed a threat. Biologists would analyze the aliens' physiology, looking for any potential risks or compatibility issues. In parallel, governments and international organizations would establish protocols for interaction with the aliens and develop guidelines to prevent panic and maintain social order. They would also collaborate to gather as much knowledge as possible about the aliens' technology and capabilities. Public awareness campaigns would be launched to inform and educate the general population about the existence of the aliens and the ongoing diplomatic efforts. Experts in various fields would engage in scientific research, trying to understand the aliens' origins. However, culture, not all citizens would react positively. Fear and uncertainty would likely lead to societal tension and potentially some negative incidents. Extremist groups and conspiracy theorists might spread misinformation and distrust, further complicating the situation. As time progresses, diplomatic negotiations would take place, with the aim of establishing a peaceful coexistence or potential collaboration with the aliens. This would require patience, open-mindedness, and willingness to find common ground and shared goals. In the long run, the encounter with aliens could have profound impacts on human society and our understanding of the universe. It may spark scientific advancements, cultural exchange, and a reevaluation of our place in the cosmos. It could also raise philosophical and existential questions about the nature of life and the meaning of our existence. Ultimately, the scenario of aliens visiting us tomorrow is purely speculative, and we can only imagine the possibilities based on current scientific knowledge. However, it highlights the need for international cooperation, preparation, and an open-minded approach to potential encounters with extraterrestrial life. Contact with the aliens. Groups of experts would record all interactions to analyze simple alien gestures and auditory reactions. Those would help to decide whether aliens came in peace or they intend to do some serious damage. Some people might believe that religious leaders should do all the talking. Something's telling me that aliens didn't learn our languages in school, so good luck to anyone trying to reach out to them. While the world's most intelligent people were busy trying to interpret the aliens' intentions to the best of their ability, weights look like some evolution experts agree that things like proteins and DNA are the same no matter where in the universe you're from. If that's true, alien evolution would be close to that of humans. They'd have binocular vision with eyes located close to the brain. Just like us, they'd be based on land and have a minimum of 2 legs for mobility and 3 fingers so that they could handle tools. Still, if some of our own life forms look like this, try to picture something coming from another planet. Meanwhile, on Earth, while governments were busy figuring out the action plan, the media would be keeping you informed. Be advised to stay indoors and wait for further instructions. It'd be hard to filter out what's legitimate news and what isn't, but try not to fall for fake end-of-the-world news on Facebook and keep calm. At least make an effort to give up the urge to pack up your belongings and head for the hills. At the same time, the governments and scientific experts would be sharing information about alien interactions from here. The events could unfold in a few different ways. First, we may not get any auditory or visual response, nothing at all. This could mean anything from the alien spacecraft doesn't have any aliens on board to the aliens are waiting for their alien backup to fry us up. Another possibility is that aliens responded and tried to communicate with no weapons involved. I can't speak to their possible intentions. For all we know, they may want to get rid of us and keep the Earth to themselves. Thanks to the language barrier, our interactions might not be going well. Tensions would begin to rise. We'd be screwed. Considering that these beings had the technology to travel to Earth, it's likely that they also have the capability to develop some very, very advanced weaponry. Civilians would most likely be hitting the panic button as hard as possible. Meanwhile, governments would put their nuclear weapons on standby. That would be our best and most destructive weapon against them. Or so we think. It may turn out that the aliens have adverse reactions to things on Earth that we're all accustomed to. If, say, their skin melted upon contact with water, then defending ourselves against them would be simple. I'm not saying aliens would necessarily bring doom upon the Earth. They may not mean us any harm at all, but if some hazardous microorganisms from outer space hitched a ride with them and made it into our world, we humans might have no natural immunity to those extraterrestrial microbes, and they could slowly wipe our species off the planet. On the other hand, if aliens weren't coming here to make friends, we'd be destroyed long before we got a chance to offer peace between intelligent beings. In any case, we aren't ready for a visit from interplanetary travelers. We better get prepared for first contact, or maybe we should try to invade alien worlds before they invade us. But that's a topic for another. What if you've been asleep for 1000 years and the view outside is not how you remembered it? Trees, wildlife, and here's what would happen if everyone froze for 1000 years. Rising temperatures, rising sea levels, declining air quality, more extreme weather, more animal extinctions, more diseases. These are just a few of the consequences we can expect if we continue to pollute the Earth, and our time to act is quickly running out. So what can we do if we want to save our planet and fast? Strangely enough, the best thing to do might be nothing. Not sit back and watch the world burn. Nothing, but everyone going to sleep and doing nothing for 1000 years while the world repairs itself from all the damage we've done. We can pretty much guarantee that Earth will be better off. But can we guarantee that you'll wake up sweet dreams? There are almost 300 cryogenically frozen individuals in the United States and 50 in Russia, and yet no one has ever been revived from cryosleep. The hope is that the technology to wake people up from cryosleep will be available sometime in the near future. Wait, what the idea behind cryonics is that humans can be preserved at super low temperatures and later restored to full health support for cryonics, is based on the fact that many living things, including human embryos, can be successfully cryopreserved, and revived existing cryopreservation techniques can even preserve the fine structure of the brain. However, we can't unfreeze a brain and make it work again yet, but suppose we perfected the process and made it possible to cryogenically preserve our world's population of 8 billion people. Where would we put everybody? The most practical setup would be to have cryosleep chambers in big facilities around the world. This would make it easier to respond to any technical difficulties that might arise while also protecting people from the inevitable decay of our infrastructure. But it's not like every human-made structure would fall apart and disappear, because not everyone would be asleep. We'd need some volunteers, appointees, or lucky winners of a draw to keep everything running smoothly. Australian geneticist Ian Franklin and American biologist Michael Soule suggest that you need at least 500 people to maintain a stable population with enough genetic variety. But with most of the world's population in cryosleep, our impact on the planet would be rolled back. Global warming would continue for another 40 years after we go to sleep. But within a few decades, our homes would break down, and within 100 years, wood structures would be gone and steel structures would begin to rust. Our cities would start to fill with plants, trees, and vines, and new rivers would form, and subway tunnels would flood without pumps working to keep the water out. After a few hundred years, many species of plants and animals would bounce back to their original levels. Before we evolved and took over the planet after 500 years, the forests would be the healthiest they'd been in the last 10,000 years. When we finally wake 1,000 years into the future, we wouldn't recognize the world outside. The planet would be lush and green, but our homes and most of our cities would be gone. There'd be lots of rebuilding to do once everyone awakes, but it wouldn't go back to the way things were. The whole reason why the Earth's population went into cryosleep was to repair our planet. We'd likely put strict laws and policies in place to ensure that our new way of life doesn't waste our critical second chance. After all, we'd still have some poignant reminders of our toxic legacy. It would take more than 1,000 years for our carbon dioxide levels to return to normal, while radioactive material and long-lasting organic chemicals could be around for much longer. Microplastics, for example, will still exist hundreds of millions of years from now, unless we find a way to help them decompose. While sleeping off the effects of climate change sounds like a relatively easy way to undo the damage we've caused to our planet, we probably won't have the technology to do it anytime soon. But can we really afford to wait? The consequences of climate change are already causing major problems around the world. Are you prepared for a lot more extreme weather? Do you know how to survive a tsunami or an earthquake? Well, we got some tips for you on our new show, How to Survive. So be sure to check it out. And if you're looking for a more hypothetical take on survival, like a timeline to human extinction, well, that's a story for another What If. 30,000 feet, 9,144 meters, 9 kilometers, or 5.7 miles. So far, only one person has survived a free fall from that height. Air resistance would you be as lucky? Out the force of gravity. For a human body in a belly-to-earth position, terminal velocity is generally around 53 meters per second, or 120 miles per hour. At this point, your main concern would be how to survive the impact. Without a parachute, your chances of survival are incredibly slim. However, there have been rare cases where individuals have managed to survive falls from great heights by sheer luck or by having something to cushion their fall, as mentioned earlier. It's important to note that attempting to grab onto something while in free fall would be highly challenging, if not impossible, due to the intense forces and speed involved. Your body would also be experiencing extreme cold and oxygen deprivation, making it even more difficult to maintain consciousness and control your movements. In the end, surviving a fall from an airplane without a parachute is an extraordinary and extremely unlikely event. It's crucial to prioritize preventive measures such as proper safety protocols and the use of parachutes to avoid finding oneself in such a situation in the first place. Air pressure below you as you fall because air can't get out of your way fast enough. And at the same time, the air behind you doesn't fill in fast enough, creating a sort of vacuum. The difference in air pressure below you and the air pressure above you creates drag or air resistance. When the force exerted by this air resistance equals the force of gravity, you've reached terminal velocity and you'll be moving at a constant speed. Falling from 30,000 feet, you're likely to reach terminal velocity at 190 kilometers per hour. Of course, your actual terminal velocity will depend on your size and weight. The heavier you are, the faster you'll fall. But if you spread your arms and legs out wide, you can increase the amount of drag exerted on you, which might slow you down a bit. You'd enjoy it a lot more if you had a parachute, though. Parachutes are lightweight and very wide. A parachute would cut your falling speed from 45 meters per second down to about 5 meters per second. If you don't have a parachute, it would help to know where to land. Look for somewhere that's soft, so if there's a chance of breaking your fall. A lot of people who have fallen from airplanes and lived have survived by landing in deep snow or being cushioned by trees or bushes. Unfortunately, a tree can either be really good or really, really bad. If you don't see anything soft below, your best bet is to try to land feet first, with your legs together and slightly bent. When you hit the ground, you'll likely crumple to the side or back. This is known as the 5-point impact sequence, and while it will be incredibly painful, it will save everything above your waist, mainly your vital organs and your brain. Of course, these are all just recommendations and tips to make the best out of a bad and severely unlucky situation. Humans aren't really built for 9,144-meter free falls, and yet every year we seem to achieve something that we thought was impossible. So before your next flight, you might want to pack a 4-leaf clover just in case. And for more ways to survive freak accidents, paranormal activities, or apocalyptic events, just keep watching What If? Could there be an even better planet for us than Earth? Scientists are searching for a super habitable world that wouldn't just rival Earth, but be a place where life could thrive even more easily. And they're looking at exoplanets. How would we discover Earth 2.0? What would make an exoplanet habitable? And how long would it take to get there? This is What If? And here's what would happen if we discovered an exoplanet that meets all the criteria for being a super habitable world. The search for Earth 2.0 has been a fascinating and ongoing endeavor. Scientists have been using advanced telescopes and innovative detection methods to identify exoplanets in distant star systems. They analyze the characteristics of these celestial bodies, such as their size, composition, distance from their host star, and the presence of an atmosphere. If we were to discover a super habitable exoplanet, it would undoubtedly revolutionize our understanding of life in the universe. Such a planet would offer conditions even more conducive to life than Earth itself. It might have a slightly higher mass, which would provide a stronger gravitational pull, stabilizing its climate and preventing temperature extremes. The presence of a thicker atmosphere could offer better protection from harmful cosmic radiation, while also retaining heat more efficiently. Additionally, a super habitable exoplanet could boast a combination of geographic features that support a diverse range of ecosystems. It may have vast oceans, lush forests, fertile plains, and abundant freshwater sources. The varied terrain would promote biodiversity and offer numerous niches. Earth 2.0 would ignite new possibilities for scientific exploration and perhaps even colonization efforts in the future. However, the practicalities of reaching this distant world raise complex challenges. Considering the vast distances involved, our current technology would require incredible advancements to enable interstellar travel within a reasonable time frame. Nonetheless, the mere knowledge that a super habitable exoplanet exists would fuel our curiosity about the universe and our place within it. It would inspire further research and fuel technological breakthroughs aimed at enhancing our understanding of exoplanets and the potential for extraterrestrial life. As we continue to venture deeper into space and uncover the secrets of the cosmos, the discovery of Earth 2.0 represents an exciting milestone in our quest to unravel the mysteries of the universe and expand the boundaries of human knowledge. Exploring the concept of a super habitable exoplanet opens up fascinating discussions about the potential for life beyond Earth and the search for environments that could support it. While Earth has been uniquely hospitable to life as we know it, the discovery of Earth 2.0 would prompt us to reconsider our preconceptions and expand the possibilities of what a habitable world could look like. One aspect that scientists would be eager to investigate on Earth 2.0 is the presence of liquid water. Water is a fundamental requirement for life as we understand it, and the availability of liquid water in different forms, such as oceans, lakes, and rivers, would be a crucial factor in determining the habitability of the planet. A superhabitable exoplanet might have a higher water-to-land ratio, with vast expanses of water covering a significant portion of its surface. This abundance of water could create a nurturing environment for diverse aquatic ecosystems. In addition to water, the presence of a stable atmosphere would be a crucial consideration. Earth possesses an atmosphere rich in oxygen, which has played a vital role in the development and sustenance of life forms. On Earth 2.0, an atmosphere with a higher oxygen content or different composition altogether could have profound impacts on the kinds of organisms that could thrive there. Perhaps unique adaptations would have evolved to take advantage of the conditions presented by the planet's atmosphere. Another intriguing aspect to explore on Earth 2.0 would be the potential for complex ecosystems and the existence of intelligent life. While life on Earth has demonstrated remarkable adaptability and intelligence, the emergence of advanced civilizations is a complex process influenced by various factors. A superhabitable exoplanet might provide conditions that could catalyze the development of intelligent life more readily, or could even have already fostered advanced civilizations. Discovering signs of extraterrestrial intelligence would revolutionize our understanding of the universe and our place within it. The quest to discover Earth 2.0 does not solely rely on technological advancements, but also on our ability to analyze and interpret the data gathered from telescopes and space missions. As our observational capabilities improve, our understanding of exoplanets and their potential habitability will become more refined. Innovative techniques, such as studying biosignatures in exoplanet atmospheres, may provide clues about the presence of life and the habitability of these distant worlds. While the discovery of Earth 2.0 may still be in the realm of science fiction, it represents an exciting frontier in our search for life elsewhere in the universe. Even if we never find an exact replica of Earth, the pursuit of superhabitable exoplanets pushes the boundaries of our knowledge and inspires us to continually question and explore the vast cosmos. As we continue to unravel the mysteries of the universe, the discovery of an Earth 2.0 would serve as a powerful reminder of the potential for life to exist in the most unexpected. The discovery of Earth 2.0 would have profound implications for our understanding of the formation and evolution of planetary systems. Studying this superhabitable exoplanet and comparing its characteristics to Earth could provide valuable insights into the factors that contribute to the development of habitable environments. Scientists would scrutinize the planet's geological processes, its magnetic field, and its interaction with its host star to unravel the intricate web of conditions necessary for life to flourish. Additionally, the discovery of Earth 2.0 would invigorate collaborative efforts between astronomers, astrophysicists, biologists, and other scientific disciplines. The search for extraterrestrial life would become a unified endeavor, with researchers striving to answer fundamental questions about the origins of life and the potential prevalence of life throughout the universe. The knowledge gained from studying Earth 2.0 could fuel advancements in astrobiology, the nascent field dedicated to understanding the possibilities of life in the cosmos. Moreover, the impact would not be limited to the scientific realm alone. The discovery of a superhabitable exoplanet would captivate the world, igniting a sense of wonder and curiosity among people from all walks of life. It would stimulate a global conversation about our place in the universe and what it means for humanity's future. The realization that Earth-like conditions exist elsewhere could revolutionize our perspective on the uniqueness of our own planet and prompt us to adopt a more proactive and sustainable approach to preserving Earth's delicate ecosystems. The quest for Earth 2.0 is not merely an intellectual pursuit. It carries philosophical, cultural, and existential undertones. It challenges our assumptions about life and our significance in the grand cosmic tapestry. The discovery of a superhabitable exoplanet would inspire us to contemplate the possibilities of interstellar travel, colonization, and interactions with other intelligent civilizations, forcing us to confront profound questions about our place in the universe and our responsibilities as stewards of both Earth and potential exoplanetary systems. In conclusion, the discovery of Earth 2.0 A superhabitable exoplanet that surpasses our own planet in its capacity to support life would be a watershed moment in our exploration of the universe. It would revolutionize our understanding of habitability, provide a fertile ground for groundbreaking scientific discoveries, and challenge our preconceived notions about life and humanity's place in the cosmos. The pursuit of Earth 2.0 represents a continuous quest to unlock the mysteries of the universe and understand the tapestry of life that may exist beyond our blue planet.